Hello and welcome to this lesson, Ion Formation. Well, before we talk about ions, let us talk about what we know, atoms. So the atoms that have a configuration or electronic configuration of either 2, 8, or 288 are said to be stable. Atoms that do not have these configurations tend to gain or lose electrons to become stable. Now, first things first. Do you remember the atom with the configuration of 2? Well, it is helium. So helium has a configuration of 2. Do you remember the atom with a configuration of 2, 8? Yes, it is neon, which is 2, 8. And finally, the one with 2, 8, 8 is argon, which is 2, 8, 8. So these three are said to be stable, and their configurations are usually called a duet or octet configuration. Now, duet configuration is for helium because it has 2 electrons in its energy shell, and octet configuration is for both neon and argon because they have 8 electrons in their outermost energy shells. Elements such as sodium, which have electron configuration of 2, 8, 1, calcium, which has configuration 2, 8, 8, 2, oxygen with configuration 2, 6. Then we also have a simple one like lithium, which has a configuration of 2, 1, are not stable because they do not have either of these 3 stable configurations. Therefore, all these plus all the others that do not have these configurations are said to be unstable. For the unstable atoms to gain stability, they need to either lose or gain electrons. Consider sodium with electron arrangement 2, 8, 1. Now, for sodium to gain stability or to become stable, it requires either to lose 1 electron, and therefore, since it has lost the outermost electron, it will just be 2, 8, and therefore this one is a stable configuration. Alternatively, it may gain 7 electrons, which will give us a configuration of 2, 8, 8, which is also stable. However, we have what we call energy that is required. For sodium to lose one electron, it requires some energy. For it to gain 7 electrons, it also requires some energy. But it is easier for sodium to lose 1 electron than to gain 7, because losing 1 electron requires less energy compared to gaining 7. And therefore, usually sodium loses an electron to become stable. Consider this second example. Lithium. It has a configuration of 2, 1. How can lithium become stable? It can either gain 7 electrons and form the configuration 2, 8, or it can lose 1 electron and form the configuration 2. Both of these are stable. But as we said, losing and gaining electrons requires energy. So lithium requires less energy to lose 1 electron than to gain 7. Therefore, lithium usually loses 1 electron than gain 7. Consider another example. Oxygen. It has a configuration of 2, 6. For oxygen to become stable, it can either lose 6 electrons and form the configuration 2, or it could gain 2 electrons and form the configuration 2, 8. In this case, it is easier for oxygen to gain 2 electrons because it will require less energy to lose 2 electrons than to gain 2 electrons than to lose 6 electrons. And therefore, oxygen usually gains 2 electrons to become stable. You can try to find out how the following elements will become stable. For example, nitrogen, calcium, magnesium, aluminium, silicon. The first step is always to write the electronic configuration. Then you check at the outermost energy level or energy shell. And see how many electrons it may require to lose or gain to become stable. Work that out, take a few minutes, pause the video, and then come back. Now let us use some structures of atoms to explain this. Consider this atom. It is an atom of sodium. It has a configuration of 2, 8, 1, and we said it is easier for it to lose one electron, usually the one in the outermost energy level. So once it loses an electron, it will form what we call sodium ion, and we write sodium ion like this. You need to include the square brackets. And also this one is known as the charge. Aluminium ion formation. In the previous class, we learned about how atoms lose or gain electrons. Electrons are usually represented by this symbol here. It's just a letter E with a negative sign superscript. When atoms gain or lose electrons, they form ions. So in this case, we're going to describe aluminium ion formation. We always have to start with the atom. Aluminium atom has 13 protons. It has 14 neutrons and 13 electrons. The protons have a positive charge. That means aluminium has positive 13 charge from the protons. The neutrons have no charge, and therefore we ignore it. The electrons, on the other hand, are 13. Therefore, it has negative 13 charge. Overall, we'll take the proton charge, add to the neutron charge. So we'll have positive 13. We add negative 13. We will get 0. And that is why we say that aluminium atom is a neutral atom, because the overall charge is 0. Now, for aluminium to form an ion, it has to either lose or gain electrons. Will aluminium lose 3 electrons or gain 5? It would probably lose 3 electrons because it requires less energy to lose 3. The resultant is aluminium ion, which we draw it like this. Since it lost the 3 electrons, we do not draw the third energy level, so we will not draw third energy level in the aluminium ion. Now it has a positive 3 charge, which we write 3 plus. And also in the symbol we write 3 plus superscript. Or if you're writing by hand, you'll write it above, slightly above. Now, do not forget to put the square brackets. Again, aluminium ion has 13 protons, 14 neutrons, and now how many electrons? 10 electrons. It loses 3 electrons. So it has 13 positive charges and now negative 10 charges. When we add the proton charge and the neutron charge, we'll have positive 13 plus negative 10, giving us positive 3. And that is why the charge is written as 3 plus. We just interchange, because when you're writing the charge of the ion, we start with the number and then the sign. In order to represent this change in an equation, we have to carry out like this. Aluminium, which is neutral, will lose 3 electrons to form aluminium ion, and 3 electrons. Now let us just have a look at this part here. Now aluminium will lose 3 electrons, meaning we subtract 3 electrons to give us aluminium ion. However, when we are writing chemical equations, we never use the negative sign. Hence, we will have to take this to the other side of the equation, just like in mathematics. And the sign will change. And hence, we will have aluminium forming aluminium ion plus 3 electrons. So anytime we find that we have a negative sign in our equations, we have to convert them to positive sign by moving the electrons to the other side of the equation. Fluoride ion formation. Fluoride ion is derived from fluorine atom. The procedure is as follows. We start off with a fluoride atom, symbol F, electron configuration 2,7. Now for fluoride atom, is it easier for it to gain 1 electron or to lose 7 electrons? It is easier for it to gain 1 electron. So usually it will gain 1 electron to form a fluoride ion. It has square brackets and the charge is negative. When you look at the fluoride atom, again, it has 9 protons and 9 electrons. Therefore, the overall charge is the charge for the protons plus the charge for the neutrons to give us 9 plus negative 9, which is 0. However, for the fluoride ion, it has 9 protons and 10 electrons. The overall charge is P plus N, which is positive 9 plus negative 10, which gives us negative 1. And that is why our charge is negative. Now remember, we do not write 1 negative, because if the charge is 1, we simply ignore the figure 1 and write the sign. Again, for the equation, a fluoride atom gains 1 electron. Again, don't need to write 1. The E minus stands for itself to give us a fluoride ion with a superscript negative sign. You can see how to write a fluoride ion. For a beryllium ion, the procedure is the same. It has got 2 electrons in the outermost energy shell. It is easier for it to lose 2 electrons than to gain 6. Therefore, beryllium will lose 2 electrons. In effect, we will also ignore drawing the outermost shell and end up with the beryllium ion. The equation is represented as follows. Remember, beryllium loses 2 electrons to give us beryllium ion with a 2+ charge. We will take this one to the other side of the equation and we'll have beryllium will lose 2 electrons to gain a stable configuration, and hence the overall equation is given here. The next one is chloride ion formation. A chlorine atom has a configuration of 287. It is easier for it to gain 1 electron than to lose 7. And hence it will gain 1 to form a chloride ion. Remember square brackets and the charge. And the overall equation is here. Again, for the chlorine atom, it has 17 protons and 17 neutrons, or 17 electrons, to give us 17 plus negative 17, 0 charge. But for the chloride ion, we have 17 protons, which are positively charged, and 18 electrons, which are negatively charged. Hence, we'll say 17 plus negative 18 to give us negative 1. But we do not write 1, so we just write the sign negative. If we calculate and find here such a figure like negative 2, then once we draw, we'll have the square brackets and we'll draw our atom there and we'll have 2 negative. Remember, we reverse, so it is 2 negative. However, for this case, it is just negative.